Hello everyone, my name is Leo Mchenje and I will be presenting on uniform density function and some useful SPSS commands. So the random number generators and tests for random number generators were done yesterday by Engineer Kusena. So I will continue from where he left. Okay, so first we will define what are probability density functions. So probability density functions are statistical measure used to gauge the likely outcome of a discrete value. For an example, the price of stock or the exchange trade fund. We can express it using probability density function. You understand more as we go. Probability density functions are plotted on a graph typically resembling a bell curve with the probability of the outcomes lying below the curve. So this is the curve that I've just talked about. So the red line here is the curve that I was talking about. So the probabilities will lie below this line. And for this example, the probabilities are from the region A to B. Anything outside A to B will be equal to 0. So f of x here is the probability density function. So in the next slide, I've added a more detailed description. X is a continuous random variable if its range space Rx is in an interval or a collection of intervals. The probability that X lies in the interval AB is given by PA less or equal to X less or equal to B, meaning the region from A to B is equal to the integral of f of x in the region A to B. So every probability density function should satisfy the following conditions. F of x should be greater or equal to 0 for all x in the region Rx. So this is the region here from A to B. This is the region Rx. Then f of x, integral of f of x is equal to 1. This means that the area under the curve from region A to B is equal to 1. If we integrate this f of x, we should get 1. Then f of x is equal to 0 if x is not in the region Rx. So if x here, this one, the x-axis, if the random variable is outside A and B, it means that f of x is equal to 0. Then the general properties, px is equal to x, px equal to x naught is equal to 0 because x, the integral of x naught to the integral of f of x from x naught to x naught is equal to 0. Then moving on to the next example. Okay, yeah, I've added an example. So the example is on the life of an inspection device is given by x, a continuous random variable with a probability density function. So our probability density function is f of x, and we have one half exponential 1/2 to the minus x to the power minus x over 2, where x is greater or equal to 0 and 0 otherwise. So if x is not greater or equal to 0, it means that x is 0. Okay, so x has an exponential distribution with mean 2 years. So the probability that the device's life is between 2 and 3 years is. So from our previous example, we used A and B here for the region, but now here we have 3 and 2. So we are going to integrate this f of x in the region 2 to 3. So we integrate, then we substitute, and we get the area of 0.145. If you integrate this, you get 0.145. So now the applications of the probability density function, we can express it if we take a look at the uniform distribution. So the reason why I chose the uniform distribution is because if you look at our topic, it also contains random numbers. So that's why I use this. It's something like a continuation for random numbers. Okay, so the uniform distribution defines equal probability over a given range for a continuous distribution. For this reason, it is important as a reference distribution. One of the most important applications of the uniform distribution is the generation of random numbers. The more detailed description of the generation of random numbers, I think it was presented by Kusena. So I'm not going to discuss more about the random numbers. Okay, so we are done with the probability density function. We are now moving on to the next section, which is some useful SPSS commands. So before we begin talking about the useful SPSS commands, for the benefit of those who doesn't know what SPSS is, SPSS is a software package used for logical based and non-based statistical analysis. SPSS can take data from almost any type of a file and use them to generate tabulated reports, charts, and plots of distributions and trends, descriptive statistics, and conduct complex statistical analysis. So let's say you are doing your research and you have data that you have collected. You can use SPSS to help you do your research to analyze the data. It actually draws graphs, it actually draws the charts, the plots, everything. It will make life simple for you when you are analyzing your data. So we will learn more about SPSS as we go. I have added the applications at the end of the presentation. So we are now moving on to the commands. So we can group the SPSS commands into three types. They are what are called procedures. Then there are also transformations and other commands. So understand this distinction will allow you to get things done in SPSS faster and more efficient. So here is an overview diagram for the SPSS commands. So here, when all SPSS commands, then when executed, when a subsequent procedure is run, or immediately when a command is run. Okay, then reads data values and command type. So when our command runs, it either when our command is executed, it either immediately when the command is run or when a subsequent procedure is run. I've also added an example of the description of this at the end of the presentation. So after the command is run, it either reads values or it does not. So if it does not read value, then it's called a transformation command. Then if it reads the value, it's called a procedure. Then if the command is executed immediately when command is run, then the command does not read the value, then it falls under the other SPSS commands. So these are the three groups that we have. So now we are going to discuss the full details on each group so that we understand more of the SPSS commands. Okay, so we are going to start with the procedures. For commands that are executed immediately, like from this diagram here, when executed. So for commands that are executed immediately, the second question is whether they read data. In SPSS, reading the data refers to the process of SPSS going through all the cases from top to bottom in the data. All commands that read the data are referred to as procedures in SPSS. Procedures do two basic things: report on the data values, descriptives, frequencies, or create or transform data with values, aggregate or rank. I've also added an example for this. A reason for distinguishing between procedures from other commands is that they do more than just their core functions. For instance, they also cause transformations to be executed and other things. Second, procedures may require a lot of time when you run large data sets. So that's the reason why they are not executed immediately. Okay, so here is a list of the procedure commands. So we have what are called descriptives, frequencies, rank, and aggregate. So descriptives generate a single table with descriptive statistics for one or more variables. It can also add z-scores to your data. Then frequencies. Frequencies are used for much more than frequency tables. It's also the easiest way to obtain basic charts such as histograms and bar charts. So procedures are the ones which are used to draw bar charts and histograms. Then rank command is used to create a variable holding the rank numbers for the values of some other variable. Rank is also used for discreting continuous variables into entire groups. Then the last one, the aggregate. These are only the most useful commands. The aggregate is used for creating variables holding statistics over cases. So we are now moving on to the next group of commands, which are the transformation commands. Some SPSS commands are not carried out immediately when you run them. Such commands are referred to as transformations. Most transformations create or transform data values. Typical examples are compute if. Then as a rule of thumb, only transformation commands can be used with loop, do if, and do repeat. So just to summarize before I explain each and every command, an if command is more like an if statement in programming. It is used to execute a certain command if a certain condition is satisfied. Then a loop is used for iteration. Then a do if is used to do a certain task if a certain condition is satisfied. So here is the descriptions for all the commands. So I will start with the loop. A loop is used for running one or many SPSS transformations commands respectively. Then the compute sets data values for possibly new or numeric numbers and string variables. This can be sum or average of certain variables. Then the if computes new or existing variable for a selection of cases. The cases here are what I was referring to as certain conditions. Then the do if. The do if is applied only to cases. Cases are rows of data that satisfy one or more conditions. Then the do repeat, often used for looping over possibly new variables. So now we are moving on to the other SPSS commands. There are quite a number of these commands. So I'll just run through them so that we head over to the applications. So there are some commands that are neither procedures or transformation. These commands perform all sorts of tasks except report on data values or create edit values. These commands can be grouped into 5. Okay, so we have what are called the dictionary commands, the system settings, data settings, control windows, and we also have other commands. So we are going to start with the dictionary. So this is the general overview of all the commands. So the dictionary, inside the dictionary, examples of commands that we have rename variables, we have value labels. Then the second command is the command family, is the system settings. Inside the system settings, we have set, show, cd, and preserve. Note that these are the most useful commands. These are not all of the commands. The commands are more than this. Then data settings, split file, filter, wait. These are examples of the commands. Then also you have control windows, get, save, dataset, active. Then under the other commands we have vector, insert, and define. So I'm just listing all the commands. Now I'm explaining each and every one of those commands in detail. So we are going to start with the dictionary commands. So what are dictionary commands? SPSS dictionary commands, they contain mostly information describing data files and their variables and values. Some dictionary information being incorrect or absent, especially missing values, variable labels, and value labels, can cause corrupt data in the numerous research conclusions. So if we have missing data, we use these dictionary commands to help us in order to obtain what maybe you can say a better conclusions. Dictionary commands are also used to repair corrupt data, so that we produce a good research which is not biased. So the first command that we have here for the most useful commands under dictionary is the add value labels. This is used to add or edit value labels. Then we have missing values. This is used to specify missing values for many variables. Let's say our data has some missing values. We use this command to repair the data. Then we have the rename variables. This is used to change variable names. Then we also have the variable labels, add or edit description of variables. Then we also have the formats. The formats set formats for mostly numeric variables. Then we also have the delete variables. These are used to permanently delete one or more variables. This is self-explanatory. Then we have the string. The string is used to create new variables before setting its values with compute, if or other command. Then the next one is the document. A document is a data file description that is saved as part of the dictionary. Then apply dictionary. This is the last command under the dictionary commands. Is used to copy dictionary properties between files or variables. Then the next commands that we have are the Windows commands. Windows commands are used for controlling windows. That will be opening on our when we are. Okay, let me first define what Windows commands are. Windows commands, starting from SPSS version 14, you can have multiple data editor windows open simultaneously, meaning you can open more tabs at the same time. These are referred to as data sets. For controlling these commands or for controlling these windows, meaning the tabs that you have opened, we use Windows commands. So the most useful ones are the ones which I have listed in this table. So the first one is the dataset name. This is used to assign name to dataset by which it can be addressed, allows working on multiple datasets simultaneously. So let's say you want to work on multiple datasets, you just specify different names for all the datasets so that you can run them simultaneously. Then we have dataset active. This one is used to choose which dataset is to be addressed by the subsequent commands. So in order to work on a specific dataset, first you need to run the dataset active to set that dataset to be active. So that when you run your commands, SPSS knows that you want to run these commands on this dataset. So we have dataset close. This one is used to close a dataset without saving the dataset. Then we have output name. This is used to assign to output window by which it can be addressed, allows using multiple output windows simultaneously. After you've run your analysis, the output, you can save the output maybe for future use. So we use this output name to assign a name to your output so that maybe you can reference it later. So we have output active as the next command. This is used to choose the output window to which subsequent output should be appended. So this one is used when you are for your output to specify where you want to store your output. You use output active. This is only when you are running multiple data sets. Then we have output close. This one is used to close output window without saving. So the next commands that we have are the system settings. So system settings control a myriad of sometimes technical SPSS settings. These settings hold for all open SPSS windows. So as you can see, this is more like a continuation of the previous command, which is the SPSS Windows commands. Okay, so the first one on the list is the CD. This one is used to set default directory, affects all commands including get, save, insert, and set C template. Then the set command is used to edit one or more settings. Then the next one we have is the show command. The show command is one or more settings. It is used to set for editing settings, use display for showing dictionary information. So you run the show command. Maybe if you are not sure of what you want to do, you just write the show command, and then it will help you use the command that you want to use. For example, the set for editing the settings, or use the display. Then the next command is the preserve. The preserve command is used to remember current settings. Let's say you have settings that you have edited and you use preserve, and then you edit the settings again and use preserve. You can use a restore function to restore back to the previous settings that you have already have. Then the restore is used together with the preserve command. So now we are moving on to the next commands, which are the SPSS data settings. So some settings are applied only to the active data set. So which distinguish them from SPSS system settings. So the commands that we use to this type of settings, these are called the data settings commands. So we have the filter command, which excludes selection of cases from procedures. Yes, it's self-explanatory. Then we have the split file. This one is used to have procedures, processes, or groups of cases separately. It is used more like to split your processes. Then we have the weight. This is used to assign weights to cases. Then the next command that we have, these are the last commands. We are almost done with our SPSS commands. So other commands, what are they? Some SPSS commands don't fit into any of the groups that we have discussed above. These include some very useful ones, such as insert vector command, the OMS. So this table shows a list of the most useful commands. First we have the include. This one is used to run in external syntax file. Then we have the vector. The vector allows variables to be addressed by index, mainly used with loop. Then we have the OMS. This one is used to start monitoring, capturing, or suppressing selected output. Then we have the OMS end. This one is used to stop the OMS that we've discussed above. So it is used to stop monitoring or capturing or suppressing selected output and show self-captured output if any. So this one is used to stop the task that we are running here on OMS. So we have the permissions command. This one is used to set file permissions, to maybe set permission to read only, so that maybe a certain file cannot be edited or deleted. It will be only read only. Then the next command is the erase command. This one is used to delete one or more external files. Yes, this one should be used carefully, because you might end up deleting files that are useful. Then the last command is the output modify. This one is used to modify output items such as tables. So we are done with our SPSS commands. We are now moving on to the applications of these commands. So SPSS is used, first we define in order to understand the applications of these commands. It's easier if we define the uses of SPSS, why we use SPSS, where it is used. So SPSS is used by the market researchers, healthy researchers. As for me, I'm more like a health researcher. Then survey companies, government entities, education researchers, marketing organizations, data miners, and many more for processing and analyzing of survey data. So the command that I've chosen the data transformation. So this one is an application for SPSS commands. So we are going to use SPSS commands for data transformation. So this technique is used to convert the format of data. After changing the data type, it integrates same type of data in one place, and it becomes easy to manage it. You can insert the different kind of data into SPSS, and it will change its structure as per the system specification and requirements. It means that even if you change the operating system, SPSS can still work on the old data. So a short description or maybe an example is below. So if you recall, when we first discussed about the transformation commands, there's an example that I said it is below under the application. This is the example that I was referring to. So for a better understanding of what SPSS transformations are, let's run one example. So for this example, open an SAV file and convert early incomes as income times 12. We'll do this by running the syntax below. Also note that for formatting SPSS commands, they are not case sensitive. So you might find they may be written in caps or maybe in small caps. They are not case sensitive. And all SPSS commands, they end with a period. As you can see from this command here, it ends with a period. So immediately after running this command, it will then SPSS will produce this table here. And here you can see it says transformation pending, meaning that it hasn't finished running these commands. Okay. Now let's run some basic descriptives of our new variable. So after running this descriptive, as you can see, where it was saying pending, it is now under yearly income. It is now displaying these values under here. Then if you go on top here, we see that these values, it was saying transformation pending. So it is executed this after a certain command was ran after. That's when it was able to display this. So to explain this, maybe in case someone was confused with this table here, I've added a more description here. Why doesn't SPSS simply execute transformation as soon as they are run? So this will answer the question here. Why it says pending here? Why can SPSS after running this command execute this yearly income? So to answer that, well, the basic answer is that doing so makes SPSS slower, especially for data that contain a vast number of cases. This also implies that using execute when it's not necessary renders your syntax slower. Although on modern computers the difference may be noticeable, but only on huge data sets. But to be safe, you don't need to run execute every time. So we have reached the end of our presentation. I hope that everybody has now a clear picture of the SPSS commands. That maybe if you're interested to go and read more on these commands, I've added the references of where I was using these, of where I got all the stuff that I've presented. These are the references. So I thank you for listening.